workshop. So when we left you last week, I was working on the extension for the locking lever for the radial arm saw with that left-hand thread. And I got the extension made up, interference fit, pressed together, ready for my son to weld it up. So let's pick up from there, starting with him welding it up. And we'll see if we can get this thing finished off, finish machining the OD in that cross pin hole. So let's get to the machining. Well, my son started to do the root pass on this with the TIG, and it was not successful. If you zoom in real close here, you can see that that weld cracked when it shrunk and started to get some big porosity in it and everything there. So something does not like welding. I don't know if it's this piece or this piece, but what I'm going to do is I'm going to take just a real light cleanup cut and try to V out the material that he laid in there, and he's going to switch over and just braze this together. So back in the lathe. I do not have a tool well suited for reaching into here. I'm going to try this, but I don't know that I have enough clearance. Maybe just barely. Maybe I can sneak up on the original 30-degree cut I took on this if I take it slow. Can't really get a good angle on this, but I'll try. Still got a ways to go. I'm not going to get rid of all that porosity. Well, certainly back to the base metal. I think I'll stop there. Hey Brennan, how's it going?
It's going.
Starting to look more like an engine.
An engine surrounded by a nest of tubes.
Yeah. So there's an inline pump. The Jettas have an inline pump between the tank and the filter. You're going to do that, right?
It's not completely necessary. The injection pump does provide its own head.
Yeah, but the problem is this thing, this is two loops. The inline pump pumps like into it and then back to the tank. And then this has the capability of pumping through, you know, from this end to this end and back to this. But with this filter, it won't suck from the tank, from what I know.
Why wouldn't it?
Because,
as I've read, you can get away with not having the pump.
Well, I guess you'll find out. Priming it might be a problem.
Yeah, I'll just take all the tubes off and fill everything with fuel as best as I can.
So you've used handmade aluminum tube radiator hoses with just like elbows fittings?
Yeah, I actually cut up a bunch of the old radiator hoses, the 20-something-year-old hoses from the Jetta.
Mm-hmm.
But they seem fine.
And these are the handmade aluminum intercooler pieces.
Intake tubing.
Mm-hmm.
I dismantled the anti-shutter valve and stuck that in front of the intake, so I have a way of manually shutting off the air if it runs away.
Okay, good. How soon before you're ready to try to start it?
Who knows? It could run now if I had the starter wired.
Mm-hmm.
It just, it doesn't have the accessory drive and the alternator to keep the battery charged. And I have to put the tank in the car.
The tank is prepped and ready. You have an additional return fitting that you put into it?
Yep.
Was this a tank you got off of Facebook Marketplace or eBay?
I asked in a Facebook group for Spitfires if anybody had one.
Okay.
And somebody had an extra.
What was wrong with yours?
It was like completely fucking clapped out. It must have been rusted all the way through in the bottom. It had a piece of sheet metal like hammered up around the bottom edge and welded.
Yeah, okay. Well, this one looks pretty nice. A little bit of...
It's better.
Yeah. All right, good deal. Everybody's looking forward to it. Thank you for the lock lever. It came out really nice.
Yeah, it's probably not as strong as it could be.
Well, it's got a 2/3 thousandths press as well, so it isn't going to ever come apart, believe me.
But I'm pretty sure I melted some of the base metal into the
braze.
So I think that makes it brittle.
Well, it'll take 20 foot-pounds of torque, which is all I'm ever going to put on it.
Yeah.
If that. Hand tight's really what it's going to be. Okay, so my son brazed these two together. We've got plenty of material there to remove. So what I'm going to do is I'm chucked onto the stud. We're going to true this OD, but first, because this does run out a bit, I don't know, maybe 20 thousandths or so. See, I'm actually pulling a chip there. I'm going to recut the center and give this some support. So I'm just going to punch a little bit of a hole in here and then put the little boring bar at 30 degrees and recut a true center to give this some support before I turn this. I'm going to take a very light facing cut so I don't wipe out the center that I just put on. Looks like it did not quite clean up, so we'll just do another 5. Okay, now I have a true OD that I can grab. I'm going to flip this and work on that surface there. Looks like I could take just a hair more without really reducing the diameter too much. I'd say that's good enough. Well, that's its new home. I'm set up here in the K&T with my Flynn Model 43B boring head. Holds a 5/8 shank tool. In basically good shape, but this thing did take a hit, was in some kind of a wreck at one point, because you'll notice once this is running here, we've got run out at the nose. I mean, I think it's all in the shank, and hopefully that can be fixed. I mean, maybe the shank will even come out and I can just make a new one, or I could heat it up and do some straightening in the lathe. But anyway, I've got a small C2 boring bar in here, and I've got it to where I'm just ticking the inside bore of the cross pin here. This thing is very oblong. I don't know what this hole was originally for. I'm set up with a V-block, just clamped in. I've got the hole pretty much vertical, and I'm centered between the jaws of the vise in my y-axis, just centered the X by I. So anyway, you know, not the greatest clamping, but this is a pretty light cut. And when I change over to put the chamfer in these holes, I'll probably just grip this directly in the chuck jaws themselves, maybe with a couple pieces of aluminum to protect it. So let's fire this up, and we'll take 10 thousandths at a time. Oh, I wanted to show you the feed setup also. The feed on the K&T is actuated by this lever, and we've got two ranges, and based on whether this knob is in or out. So the in are the real fine feeds from 1.6 thousandths, or excuse me, the out are the real fine feeds, 0.2 to 1 thousandths, and the in is 1.6 to 8 thousandths. So right now this is in, and we're on range A, so that's a 1.6 thousandths feed. I want to get up to maybe, let's go up to a C, a 5 thousandths. So we just flop that up to there, and we'll go ahead and pass the cutter through at this feed before I increment it out. Conventional right-hand rotation. Should mention that I've got my quill stops set so that when we get through to the other side, the down feed will stop. See if I can show you how fast my down feed is progressing. We'll watch the feed lever here. And you'll see that feed lever kick up when it's down to all the way there. There we go. I'm just being conservative here, giving it 5 thousandths per increment. I don't know if you can see that wobble. Let's try 10 thousandths. See what it sounds like. I'm a long way from where I'm touching on all sides. And if you look in there, you can see that it is cleaning up. Both sides in the axial direction, and not at all side to side. Little continuous curls. Let's see where we are. Boy, it's a nice looking bore. Looks like we're right at 600 thousandths. So maybe 625 would be a nice dimension to clean that up to. I can't remember if I incremented the head or not. I don't think I did. I can power up. Maybe that would act like a spring pass, although the lead of the cutter isn't there. $6.10. So one of the things I was wondering is this dial reading in diameter or radius as I increment 5,000. So we're at 610. I incremented this 5. We'll measure again and see where we're at. Couldn't find a gauge pen, but I did find a 5/8 solid carbide tool. Oh yeah. Beautiful. I don't know if you can see the finish on that hole. Got a tiny bit that didn't clean up. Now we'll put a nice chamfer on that edge. Now for those of you who watch my channel, probably seen me do this before. I've got a solid carbide 1/2 inch shank 45-degree chamfering bit in here, and I'm still on center with this hole. I'm going to see if this setup is rigid enough as is, and I'm going to walk a circle, take light cuts until I completely clean up the edges of this. I'm watching the clearance to my U-clamp over here. Okay, I'm touching. And I'm only going to be touching at the high sides initially. I don't feel much going on back here, so I think it's rigid enough for what we're doing. We'll take another few thousandths for a cleanup pass. There's the effect I was after. I'm definitely happy with that. Real nice fit for a 5/8 round bar. Remnants of my centering hole there. So I'll put this back in the lathe and polish the surface with some 220 or maybe even a little finer, go up to 400 or so, give it a nice satin finish. And you notice I got that nice 45 chamfer on the hole there, just enough on the edges so that this won't be a sharp edge. Tiny bit of area there on the sides that didn't clean up due to how oblong that hole was, but hey, I'll take it. I call that a win. Well, I hope you enjoyed that. Man, it's another one of those sweltering days, hitting about 100 degrees here in Virginia, but at least I got that piece knocked out. And I think next week I got a couple new items of tooling I wanted to show you, so that should be interesting. And we'll actually get started on repairing, walking that bore in that radial arm saw casting and cleaning up that weld so that the rotational, that slug that fits in it, can be locked down again, hopefully. So thanks again for watching and for subscribing. Try to beat the heat and stay cool. And until next time, as always, from Engineers Workshop, stay safe.